This is a course on assembly language programming. This is a beginning course. While there are no prerequisites for the course, it's assumed that you have some computer familiarity. For example, the course begins with a review of the binary system. If you're familiar with Boolean algebra, you won't have any problems with it. The course covers just the parts that you'll need to know for the upcoming operations. However, if you are new to the base 2 number system, you may need to do a little outside studying. There is nothing difficult about it, but if you've never seen it before, it can be confusing. You will need to have a few things to be able to run the programs and to perform the experiments described in the lessons. You'll need to have a few basic items. First, you'll need either a Linux or a Windows computer. Programming examples for both systems are presented, and many of the examples will run as they are on both systems. Now, on this computer, you'll need a text editor. Anything that makes it possible to edit simple ASCII files will do. I have my own editors, and I use those throughout this course to demonstrate the code listings, but I don't make any text editor recommendations. That's up to you. You will need a C compiler. It's used in two ways in the course. For one, when you write assembly language programs, you often want to link them in as functions and call them from other languages, and I'll show you how to do that. For another reason, doing input and output in assembly language can be tedious, as you will see, so the C routines can be used for that purpose. Makes it a lot easier to demonstrate how the assembly language works. You will need an internet connection to be able to download and install the assembler used in the course, and finally, you will need patience. Assembly language programming is not something that happens fast. It takes time. Even to do the simplest chores, it takes time. Many tests have been made of programmer productivity, and results indicate that a programmer produces the same number of lines of code no matter what language is being used. And it takes a lot more lines of assembly language to do something than it does in other languages. I've already mentioned Boolean algebra, and that's what the course starts with. The next thing covered is the computer as seen from its inside. You need to understand the CPU and the registers and how memory is addressed. Then the NASM assembler is explained. It is freely downloadable and is used for all the examples shown in this course. Then the course takes a look at the construction of a program. This includes the details involved with a single instruction and the overall construction of a program. This is the largest section of the course and is filled with a number of examples. Macros began with assembly language. In a way, assembly language macros were the predecessors to higher-level languages. Macros come in handy in hundreds of ways. They're a very important part of assembly language programming. Boolean algebra is visited again, but this time from the viewpoint of a Boolean operation performed by the CPU. Assembly language functions and function calls are very important. One of the most useful things you can do with assembly language is to write functions. Aggregate data includes arrays and data blocks, structures. This includes addressing C structs and C bit fields. Floating point numbers work entirely different than integers do in assembly language. There are other assemblers, there are debuggers and utilities and so on. This last section is a review of them. Those are the highlights of the course, but there are other details included here and there. The course is aimed at someone who already is a programmer but wants to be able to program in assembly language. So there is nothing about programming or methodology or style or anything other than the mechanics of assembly language. You don't need to know anything about programming to take the course, but the better you are at programming, the easier this course will be.